All right, thank you everyone. Welcome to section 1.4, complex numbers. So the complex number I is equal to the square root of -1, and I squared is I squared is I times I, which is square root of -1, times the square root of -1, which gives us -1. And the standard form of a complex number is written as a plus bi, where the a can be any real number and the b can also be any real number. For example, we can write, let's say, 2 plus 3i. So this is the complex component, and this is a real component. All right, so first of all, let's begin by looking at adding and subtracting. Complex numbers. Let's see how we add and subtract complex numbers. For example, this is example 1. For example, if we have a, we have 5 minus 2i plus 3 plus 3i. So when we have this, we subtract the real numbers part together, and we also add or subtract the complex number part together. So this becomes the real numbers together, 5 plus 3, and plus the complex numbers together, 3 minus 2 times I, right? We add up the real part together. We also add up the complex part together. So this becomes 8 plus I as our answer. Let's look at another one. B, if we have 2 plus 6i minus 12 minus I. So we subtract the real part together. So 2 minus 12 and plus 6 minus I, so 6 plus I. 6 plus 1 times I. All right, so this becomes -10 plus 7i. All right, let's look at another example. Where we try to multiply complex numbers. For example, if we have a, we have a 7i times 2 minus 9i. We multiply through by 7i. 7i times 2 minus 7i times 9i. 7i times 2 is 14i. And minus 7i times 9i is 7 times 9 is 63, and I times I is I squared. So this becomes 14i minus 63 times I squared, which is -1. So this becomes 63 minus negative 63 times -1, which is positive 63. So this becomes 63 plus 14i. All right, so let's look at some additional examples. So suppose we have 5 plus 4i times 6 minus 7i. All right, so 5 times 6, we have 5 times 6 minus 5 times 7i plus 4i times 6. So 4i and times 6 and minus 4i times 7i. All right, so 5 times 6 is 30, minus 5 times 7i minus 35i, 4i times 6 is 24i, 4i times 6 is mm, 4i times 6 is 24i, so plus mm, so plus mm, plus 4i times 6 is 24i, and minus 4 times 7 is 28, and I times I is I squared. All right, so this becomes 30. Okay, so this becomes so this becomes this becomes 30 minus 35i plus 24i is 11i, so minus 11i plus minus 28. So it becomes 30 minus 11i and minus 28 I squared, and I squared is -1, so my times -1. So this becomes 30 minus 11 I plus 28. So this becomes 58 minus 11i. Um, let's look at something that we call the conjugate of a complex number. Conjugate of a complex number. So the conjugate of a complex number a plus bi is a minus bi. And the product of two complex numbers a plus bi and its conjugate a minus bi is equal to a squared plus b squared. For example, 2 plus 3i times 2 minus 3i. This equals to 2 squared plus 3 squared. And 2 squared is 4, 3 squared is 9. So this becomes 13. Because if you expand this, 2 times 2 is 4. 2 times negative 3 is negative 6i. 3i times 2, positive 6i. 3i times negative 3i is negative 9i squared, right? And 6i, negative 6i plus positive 6i is 0. So we have 4 plus minus 9i squared, which is negative 1. And this becomes 4 plus 9, which is 13. So let's look at complex number division. Let's look at complex number division. Let's look at this example. If we have 5 plus 4i divided by 4 minus I. All right, so this becomes 5 plus 4i divided by 4 minus I times the conjugate of the denominator, which is 4 plus I divided by 4 plus I. Okay, so this becomes 5 times 4 is 20. 5 times I is 5i. 4i times 4 is 16i. And 4i times I is 4i squared. So 4i squared. And this divided by 4 minus I times 4 plus I. And that is a squared. That is 4 squared plus 1 squared. Remember we said a plus bi times a minus bi is equal to a squared plus b squared. So that means 4 minus I times 4 plus I is equal to 4 squared plus what's in front of the I is 1, but we don't write it. So 4 squared plus 1 squared. So this equals to 17. All right. So here we have 20. We have 20 plus 5I plus 16I is 21I. And plus 4 times I squared is -1. And this divided by 17. So this becomes 20 plus 21I and minus 4 divided by 17. So this becomes 16 plus 21I divided by 17. All right. And we can write this also in standard form as 16 divided by 17 plus 21 divided by 17I. Okay. All right. So let's look at the principal square root of a negative number. All right, the principal square root of a negative number. So the square root of a number such as negative b is the same as square root of b times -1, which is the square root of b, and the square root of -1, which is equal to square root of -1 is I, and this becomes I square root of b. All right, so example. The square root of -121 is equal to the square root of I 121. The square root of 121 is 11, so this becomes 11I. And b, the square root of -80 is I square root of 80, which becomes I square root of 80 is square root of 16 times 5, which becomes square root of I square root of 16 times square root of 5. And this becomes 4I square root of 5. And C square root of 7 squared minus 4 times 5 times 4. This is equal to the square root of 49 minus This is equal to the square root of 7 squared is 49. 4 times 5 is 20. And 20 times 4 is 80. So 49 minus 80. And this becomes a square root of negative 31, which is I square root of 31. All right. So let's look at operations involving square root of negative numbers. All right, so let's look at some operations involving square root of negative numbers. Let's use this example 6, which says we are going to perform the indicated operations and write the result in standard form. Since perform the indicated operations and write the result in standard form. All right, so the first example is the square root of negative 27. So A square root of negative 27 plus square root of negative 48. All right, so negative square root of negative 27 is the I square root of 27 plus I square root of 48. And 27 is the square root of 9 times 3 plus I square root of 48 is 16 times 3. All right, so this becomes I square root of 9 times square root of 3 plus I square root of 16 times square root of 3. So this becomes square root of 9 is 3. So this becomes 3I square root of 3 plus square root of 16 is 4. So 4I square root of 3. And we can add these two up to be 7I square root of 3. All right, so let's look at another example. All right, so let's look at another example B, where we have minus 2 minus square root of 3 all squared. So this is minus 2 minus square root of 3 times minus 2 minus square root of 3. So this becomes negative 2 times negative 2 is 4. And negative 2 times negative square root of 3 is 2 square root of is 2 square root of oh, okay, so this is 3I. I think I did not write this down properly. So this is 3I here. So this is I here, of I here. So negative 2 times negative 2 is 4. Negative 2 times negative square root of 3i is a positive 2 square root of 3i. Negative square root of 3i times negative 2 becomes positive 2 plus negative. Let me write it as equals plus positive 2 square root of 3i, and negative square root of 3i times negative square root of 3i becomes positive 9 positive 3i squared. All right, so this becomes 4 plus 4i square root of 3, these two added together becomes 4i square root of 3, and plus 3 times negative 1, since I squared is negative 1. And so this becomes 4 minus 3 is 1 plus 4i square root of 3. All right. So let's look at how we simplify different powers of I. And I power 1 is equal to 1 is equal to I power 2 is equal to I times I, and I is the square root of negative 1 times the square root of negative 1. So this becomes negative 1. I power 3 is the same thing as I squared times I. So this becomes negative 1 times I. So negative I. And I power 4 is I squared times I squared. So this is I squared is negative 1. So this becomes negative 1 times negative 1, which is positive 1. All right, so let's look at some examples. So let's look at some example. For example, A, we have to simplify I power 65. All right, so the key here is knowing that I power 4 is equal to 1. And so if we raise any higher power to a multiple of 4, then the result, the multiple of 4, then the result of that will be 1. And so that will simplify things for us. So 65, let's break 65 into a multiple of 4, a multiple of 4, and add the quotient to it. So 65 is equal to 4 times 16, which is 64, plus 1. So that means I power 65 is equal to I power 4 times 16 plus 1. And so this equals to I power 4 times 16 times I power 1. Right? And I power 4 is 1. So this becomes 1 power 16 times I power 1, right? And any number power, 1 power any number is still 1. So this becomes 1 times I power 1, which becomes I. So 60, I power 65 can be simplified to I. All right. Let's look at another example. Let's look at another example. B, I power 72. So let's break 72 down into a multiple of 4 times another number. So 4 divides 72 18 times. 72 is equal to 4 times 18. So we can write I power 72 as I power 4 times 18. And so it's equal to I power 4 times 18. And I power 4 is 1. So this is 1 power 18. 1 power any number is still 1. So we get 1 for this. So this is how we simplify I power 72. The key is we have to break it down into a multiple of 4, because we know that I power 4 is 1. And so when we do that, that simply speeds up a lot of the simplification for us. All right, so thank you. This is where we bring an end to section 1.4 on complex numbers. I'll see you in the next one.